Let's finish writing the constructor. In a previous coding session, we started out with the clam contract and we called a function called tickSpacingToMaxLiquidityPerTick. If I open this file, you can see that we have a to-do here where the code is empty. So in this video, we're going to be implementing this function. The basic idea of this function is that it's going to return the max liquidity between two ticks. This will be the maximum liquidity that is possible divided by the number of ticks that are available. Let's open the Uniswap v3 implementation and take a look at the code. So over here, inside the Uniswap library, there's a file called tick.sol, and we have the function tickSpacingToMaxLiquidityPerTick. The first line rounds up the tick to a multiple of tick spacing. And this is accomplished by first dividing minimum tick by tick spacing. And by doing this, it will truncate any decimals. If this was a positive number, this will round down the number. However, since min tick is negative number, it will round up. And then once the number is rounded up, it multiplies by the tick spacing. Similarly, we do the same thing for max tick. Max tick will be rounded down to a multiple of tick spacing. And again, we do that by dividing max tick by tick spacing. Division and solidity truncates the decimal parts, and then we multiply by the tick spacing to get a number, max tick, that is a multiple of tick spacing. Once we have max tick and min tick, we take the difference, divide by the tick spacing to get the number of ticks, and then add 1 to round up. Once we have the number of ticks, we divide it by the max liquidity. Max liquidity, what you see over here, type uint128.max is the maximum liquidity. We can check this by going to a Uniswap v3 pool, and under liquidity, this data is represented as uint128. So the max of liquidity will be the max of uint128, which you see over here. Max of liquidity divided by the number of ticks. This is how we will get the maximum liquidity between two ticks, where the two ticks are separated by tick spacing. Okay, let's implement this code into our code as well. First thing that I'll do is create a file called tickmath so that I can define min tick and max tick. Now, if I open the tickmath library inside Uniswap v3, I can see that the constants that we need are over here. However, if I scroll down, there is some complex math that I will not cover in this video. So what I'm going to do is I'm going to copy all of this file over to our code. So copy this code and then go to our code. I'll create a new file called tickmath.sol, and inside our new file, paste the code from Uniswap. And lastly, I'll change the Solidity version to match our version. So I'll copy this and then replace this version with our version. Okay, next, let's work on tick.sol, tickSpacingToMaxLiquidityPerTick. And what we're going to do is copy the code from the Uniswap code, and we'll copy it line by line. First, we'll need to import tickmath. So I'll say import from current directory, import tickmath.sol. And then next, let's first get the min tick. And the way we get it is by calling int24 min tick is equal to. We're going to be rounding up the minimum tick to a multiple of tick spacing. And we do that by typing tickmath.min tick. Divide this by tick spacing, and then multiply by tick spacing. This will get us a min tick that is a multiple of tick spacing. And we'll do something similar to get max tick. Copy this, paste it, change this to max tick, change min tick to max tick, and the rest is the same. To get the number of ticks between min tick and max tick, what we'll do is say uint24 num ticks is equal to max tick minus min tick. This will give us the number of ticks between min tick and max tick, and we'll need to divide this by tick spacing to get a number of ticks where the difference between two ticks will be separated by tick spacing. We'll need to cast this into uint24, so say uint24. And then lastly, we'll round up in case that this expression over here rounds down, plus 1. And the last step is to divide max liquidity by the number of ticks. Return type uint128, that's the max liquidity, divided by num ticks. Okay, that completes the function for tickSpacingToMaxLiquidityPerTick. Let's try compiling the contract. I'll open my terminal and then type forge build. Okay, I see an error for the code that we copied, tickmath.sol. I guess this code was fine for Solidity version less than 0.8. So let's go fix this problem. It's on line 25 of tickmath.sol. So going to line 25, max tick is of type int24, and we cannot directly cast it to uint256. What we'll have to do is first cast it into int256, and then cast it into uint256. There might be similar problems, but let's try compiling again. Forge build, and our contract compiles. Okay, that completes the constructor. In the next video, we'll start working on the function initialize.